This lesson is about atomic structure. Pretty much everything that we see and feel are made of atoms. For instance, this diamond, bacteria, iron nail, Einstein, everything that we're able to see here. And if you look up the sky, the universe, the stars, everything is made up of atoms. Even the air that we're able to feel and breathe in, they're also made up of atoms. Now this lesson is about how the atoms look like and their structure. Go to the next page to find out more about atomic structure. Atoms are the smallest particles that can exist on their own, but atoms themselves are made of these smaller particles called subatomic particles: nucleus, protons, neutrons and electrons. Nucleus refers to the part of the atom, but protons, neutrons and electrons are collectively known as subatomic particles, which this means they are smaller than the atoms and they are parts of an atom. Now we'll also be looking at this term relative charges and masses, which means for these three particles what their charges are and what their masses are compared to each other. That's what we call that as relative mass. In atomic structure, we'll also be learning about energy level, or sometimes referred to as shells. Click on the next slide to go into atomic structure. What you see here is a simple version of atomic structure. In the middle of the atom, the dark circle, that's what we call as nucleus. And this is where you find the protons and the neutrons. These structures here, which are circles around the central part of the atom, which is a nucleus. So there are circles drawn here, which are called as shells or energy levels. The first energy level is here, second energy level, third energy level, and fourth energy level, and so on. And the energy increases as you go away from the nucleus. It's also important to recognize that the electrons are found on these shells going around the nucleus. And next we're going to be looking into the charges, but before that let's label these two parts as well, shells, and what you see here is electron. You also see many electrons here, 2 plus 8, 10, 12 electrons shown in this case. Click on the next page to learn more about subatomic particles, their charges and their relative masses. You will also learn about how an atom is neutral. You can see here how protons, neutrons and electrons compare in their masses and their charges. If you look at protons and neutrons mass, they are the same, and bear in mind this is not in grams, this is just a relative mass showing that the mass of proton is exactly equal to the mass of neutron. But if you look at the mass of the electron, it is very less, 0.0005 of the mass of neutron or proton. That's what it means. It is compared to the protons and neutrons, the mass of electron is very, very less, almost zero. Now the relative charges of proton is +1 and that of electron is -1. So they have equal and opposite charge, protons and electrons. Neutrons have no charge, zero charge. For a given atom, how do we figure out the number of neutrons, protons and electrons? You can do this by referring to the periodic table, and to have a look at how this is done, go to the next page. You can get information about the number of protons, neutrons and electrons in any given atom by using the periodic table. For example, let's look at sodium here. As you can see here, sodium has got two numbers on its symbol. One is a bigger number and the other one is a smaller number. So I'm going to rewrite this number, these numbers here, Na 23 and 11. Now the bigger number represents the number of neutrons and protons. So I'm going to write that here, neutrons plus protons. And the smaller number here represents the number of protons sodium atom has. Now, if you want to know the number of electrons, it's going to be exactly equal to the number of protons, because every atom is neutral because it has the same number of new electrons and protons. If you remember from previous page, electrons and protons have opposite charge. Protons have positive and electrons have negative. So if in an atom they are present in equal numbers, they cancel each other out and the atom is neutral. But it is important to remember that the smaller number of the two is just the number of protons, but it just is equal to the number of electrons. So I'm going to write it here as this is the same as the number of electrons. So if you want to know the number of neutrons, all you have to do is take away the bigger number, the smaller number from the bigger number. So it's 23, take away 11, that gives you 12. So you have 12 neutrons. So let me summarize that information very quickly. So look at a particular symbol of an atom if you want to know the number of neutrons, electrons and protons, and look for the smaller number, that is the number of protons. Smaller number is also equal to the number of electrons. So you got protons and electrons by just looking at the smaller number. If you want the number of neutrons, you just take away the smaller number from the bigger number. So 23 take away 11, that gives you 12. That gives you the neutron number. You should also know that this number, the number of protons, is referred to as atomic number of an element, and the number of neutrons and protons put together, that's the bigger number, is referred to as the mass number of an atom. So remember, the bigger number, which is the number of neutrons plus protons, is referred to as the mass number, and the small number is referred to as the atomic number. So the atomic number is equal to the number of protons, the mass number is equal to the number of protons plus the number of neutrons. It's time to check your progress. Can you describe atomic structure? Can you draw and label a simple atom and label its parts? Can you state the number of protons, electrons and neutrons for these atoms here? You can use the information in the periodic table. The answers to questions 1 and 2 are not given. It's on slide number 3, so you can go back to slide number 3 and check your answers. But the answers for these will be given. But pause the video now, try this out yourself, and then come back and check the answers.